So those of you online, if you are interested and you want to collect a copy of our end of year revision kit, feel free to go to any of our centers to collect it. Okay, but you have to come down physically. We can't afford to mail it out to every one of you. Okay, we'll begin today's lesson. So just a quick introduction. Welcome to OVERMUGGED, the Bukit Timah branch. And this is our end of year Sec 3 A Math revision event. So the topics that we'll be covering is only Sec 3 topics lah. Okay, so just a quick introduction. Okay, it's very awkward, my face is there. But okay, hello, I'm Miss Eileen. I'm OVERMUGGED Secondary, IP and JC Math Tutor, but with OVERMUGGED, I mainly specialize in O-level and IPA Math. So just some introduction, I have like 5 years worth of teaching experience and I've been with OVERMUGGED for about a year. Okay, so it's like, I'm not some random tutor that just come along the way and start teaching math, okay? I have some credentials. So just more information about me. I studied, I graduated from NUS and I studied statistics, mathematics. So yeah, I'm qualified to teach math lah. Okay, and my mantra is math is fun, okay, once you get it. Okay, it might seem very intimidating at first, like this is bullshit, math is not fun, it's very difficult. But I'm telling you, once you are able to grasp the concept and you understand what is going on, math is really very interesting because especially A math, you will realize that the topics, the questions are always repeating. So once you get it, you get it. And don't be shy to ask any questions, okay? I don't want any one of you guys to walk out of the classroom having a lot of questions or being more confused than you were before you step in. So don't be afraid. If you have any questions, please let me know. I will definitely give you guys some time to, ask me any questions if you have anything that you're unsure about. Okay, so just a brief introduction. And for the overview today, okay, what we'll be doing for today's class. Okay, we will only be covering 3 topics because unfortunately we only have less than 2 hours or about 2 hours. We will be covering quadratic functions, which is your chapter 1. Inequalities, equation and inequalities, which is your chapter 2. Some of you in school, actually, you might take this as your 3rd chapter because you might have learned certs as your 2nd chapter. And the last thing we'll be covering today is your exponential and logarithmic function chapter, which is where a lot of students struggle, the last one. Okay, there's another topic that most of you might actually also be struggling with, which is binomial, but unfortunately, we don't have time for that chapter today. Okay, so the main takeaway for today's lesson, okay, is we'll be recapping key concept and common mistakes to avoid. So these are, as a tuition teacher, when I see this kind of common mistakes, right, I can tell you these are the common mistakes that students keep making. So I'm telling you guys to avoid making them in today's lesson and help you guys reinforce key concepts you need to know for every single chapter. And this today's lesson also aims to help you all identify common question types that will appear in exam and the basic or common methods to tackle them. And also I'll be providing some checking and memorizing tackling tips that you might not have learned in school or might not have heard it from your school teachers. Okay, and if I'm going too fast, I tend to speak a little fast sometimes. Please let me know if I'm going too fast, or if I'm going too slow, you can feel free to let me know to quicken up my pace. Can everyone here all right? Okay, so just not to stress y'all out lah, but just let y'all know you only have about 1 month to your end of year exam. Most of your end of year exam is probably 4th to 9 October, somewhere around there. So it's about 4 weeks, give and take. Okay, in these 4 weeks, if you find yourself struggling a lot with A math, what you should do is you should spend the next 2 weeks revising on your key concepts. Okay, you should revise on your key concepts. And then after that, 2 weeks going to your exam, you should already be focusing on doing a lot of practice paper, a lot of exam questions. Because for math, really, practice makes perfect. If you don't practice, right, you will find yourself when you read an exam question, you feel very stuck. You don't know how to start. So to avoid feeling stuck, to avoid feeling like, oh, I have no idea what is the next step, you really got to push yourself to do practice papers. Okay, practice papers can come in the form of school past year exam papers, which are really good examples of practice papers, or your TYS. But don't go and do the topics that you haven't learned before lah. Do the topical TYS on those topics that you learn in Sec 3. Okay, and then let's formally begin today's lesson. So, Okay, sorry, hold on. I think there's someone outside. Give me a moment. Yes, this is the section. So we have already started on the introduction. So we are going on to the lesson now. Okay, someone asked if there are any worksheets to print. Yes, okay. For those of you who just joined online late, previously I already sent the link, okay, to download today's worksheet. Access the link again. I'll be resending the link. Access this link and download session 1. Okay. Okay, so let's begin today's lesson. So, oh yes, this is the OVERMUGGED math team. I'm one of them clearly. So yeah, we have OVERMUGGED, we have A Math, E Math, O Levels, IP Math, and JC Math. Okay, this link, this QR code here is very useful. It's a lot of free resources you guys can actually tap into. So please don't throw away your paper or throw away the e-copy of the notes. If you click on this, if you scan this QR code, you will be able to get, free chapter summaries, practice questions and all. Okay. So yeah, and yeah, the content we'll be covering today. So basically it's just, quadratic functions, equations, inequality, exponential and logarithm function questions. Okay, so let's formally begin the content, quadratic functions. Okay, in your lower sec, you did not really learn about quadratic curves. You mainly learn about linear curves, linear lines. Linear lines are going to be your y equals to mx plus c. Okay, if you all don't know what is y equals to mx plus c, please start revising. Quadratic functions is something that will have, x squared will appear in your equation. You will see something of a power 2. So this is immediately, every time when you see a power 2, you will know that immediately this is going to be a quadratic function. It can look like this, it can look like this, it can look like this. So long as there's a power 2 and the highest power is a 2, that will be your quadratic curve. Okay, so this is how your quadratic function look like. Okay, as we mentioned, this is your quadratic term, your linear term, because x there's no power. Not no power, there's only a power of 1. Okay, so this is your linear term and this is your constant term. So you don't really have to know what is called what lah. You just need to know that for a quadratic curve, you definitely need an x to the power of 2. Okay, and your coefficient of x squared is really important because your coefficient of x squared tells you the shape of the quadratic curve. Do you all know that? Okay, if it's your coefficient of x squared, that means a. If your a is bigger than 0, okay, if your a is bigger than 0, your curve is going to be a U shape. If your a is smaller than 0, your curve is going to be an N shape. Your U shape will come with a minimum point. Your N shape will come with a maximum point. How to remember this? You tell yourself, okay? If a is bigger than 0, a is positive. Positive people usually are smiling, right? So the shape of the curve will be a smiley face. That's why it's a U shape. If a is negative, the person is feeling very negative. So usually they'll be sad, they'll be frowning. Therefore, it's a sad face and the curve is a N shape and therefore it comes with a maximum point. Okay? So this is what this page is basically trying to tell you. Okay, let's move on. To find the maximum and minimum value of a quadratic curve. Okay, something to note about the word value first. Value and point are very different. Okay, if the question is asking you for maximum point or minimum point, okay, max point, minimum point, basically you hear the word point lah. They're asking you for a coordinate. You need to provide both your x coordinate and your y coordinate. Okay, this is if they're asking for maximum minimum point. But if they're asking you for maximum minimum value, this is different already. Value is only asking you for the y coordinate. So example, if the curve, okay, you know that the maximum point is at 5, 10, for example. The maximum value is actually 10. It is not 5, 10. Value is only asking you for the y coordinate. You need to know all this. Why? Because if the question asks you for maximum value, you go and present your answer as maximum point, you get like half a mark or 1 mark deducted for no good reason, just because you never answer the question properly, but you actually know the answer. So please take note, know the difference between value and point. Okay, so coming back to the notes, there are 4 known ways to helping you find the maximum and minimum point of value. Okay, but you only have learned 3 so far. The 4th one, ignore it for now because you're Sec 3, you will learn it in Sec 4. The first one is your completing the square. Do you all know how to complete the square? Okay, some of you look very confused. Okay, completing the square is basically you are given an expanded version of your quadratic equation. You want to squeeze out squares. Okay, you want to squeeze out a square term. That's why the method is even called completing the square. You are literally completing a square, squeezing out a square. How do you do that? Okay, this is actually the formula. If you don't know how to do this, you need to revise. It's very important. Guarantee you every single A math or even E math exam will require some sort of completing the square. Okay, for example, how do I complete a square? Okay, this might look intimidating, so let's use an example. I have this particular equation over here. What I like to tell my students is, when you're completing a square, always throw out the constant term first. Throw it out, put it aside. Don't make your life difficult. If you take into account this constant term first, I guarantee you, your completing the square working will look more complicated than it should. So what you do is you push the 10 aside first. You focus on the terms with the x and the x squared. After that, you need to make sure that whenever you're completing a square, your x squared term must be coefficient 1. Okay, must be coefficient 1. Right now, is it a 1? Clearly not, right? It's a 2. So because it's a 2, you need to take out the common factor 2. Okay, you need to take out a factor 2. But if you take out 2 from x squared, remember, we only threw the constant aside. We still have a 8x over here. So we also need to take out the 2 for the 8x. That's why there is a 2 bracket x squared plus 4x over here. Can y'all follow? Okay, so, if y'all cannot follow, please let me know, those online. So right now, the next step is you are literally, the method is literally called completing the square. You want to squeeze out a bracket square term. What have you learned about square terms? In Sec 2, you have learned your 3 quadratic identities. These are your 3 quadratic identities. Okay, a square plus 2ab plus b square. This is your first one. Your second one is the minus version. Okay, if you all don't know this, can let me know after class. Okay, and your third one is this particular one over here. Okay, these are your 3 quadratic identities, and they are really important because when you're completing a square, you are actually trying to force either the first quadratic identity or the second quadratic identity out. You're literally trying to squeeze it out. How do you squeeze it out? Is it right to say that if you have this thing over here, it is equivalent as you can have this thing over here? It is, right? Because they are literally equal. So what you are doing in completing the square is you are literally trying to squeeze this thing out for it to happen. You are trying to force this thing out so that you can get this thing over here. Okay, if it sounds confusing, let's look at the example again. Right now, we have a 2x plus 4. But can you see over here, we need 3 terms. But right now, inside the bracket, we only have 2 terms. So we need to bring a third term along. And the third term you bring in is always going to be a constant. How do you know what constant you need to plug in here? You tell yourself, this is going to be x squared. This is a plus. This is going to be a plus 2ab. Can see that? So you need to add a plus b square over here to squeeze this thing out. You have your x square as your a square. You have, you have your 4x as your 2ab. The fact that your 4x is a 2ab, can you see that your b is actually a 2? Can you all see that? Okay, your b is a 2, therefore your b square is a 2 square. which is a 4. So you are trying to squeeze out the quadratic term by adding in a 2 square so that you can get this portion over here. You can squeeze this thing out over here. Once you squeeze it out, right? You realize that to squeeze it out, you need to add in a 2 square, right? But you cannot just change the question out of nowhere. You need to make sure that your question remains the same. So what do? Because you added a 2 square, it's not just a 2 square, you added a 2 square times 2. Can see that? So if you added a 2 square times 2 previously, you need to minus that same value. 2 square times 2 is going to be 2 times 4, which is a 8. That's why you need to put a minus 8 outside to compensate for the 8 you added in. Okay? And then after that, once you have this equation over here, you will realize that, oh, I already squeezed this entire thing out. It means that I have this thing already. So it means that I have a x plus 2 square plus 10 minus 8, which is just a plus 2. Can see that? This is how you do completing the square. Anyone has any question? Okay. This is your very basic algorithm of completing the square. Just take note, it's not all the time you are squeezing out the quadratic equation number 1. Sometimes you need to squeeze this out instead. If there is a negative sign in front of your x, okay, you will be using the second identity instead of the first. But the algorithm, the thought process is exactly the same. So why do we need to know completing the square? This question, this page is trying to tell you that completing the square can help you find the maximum or minimum point. When you complete the square, you get this particular form over here, right? The value outside is actually the y coordinate of the turning point. The value inside, you need to flip the sign and you will get the x coordinate of the turning point. So, for example, this particular question, the coordinates of the turning point will be -4.5, -8, 1/4. Can see that? Okay, question is this a maximum point or a minimum point? Can anyone tell me? Okay, some of you are mouthing the correct answers really. Yes, very good. It's a minimum point. How come you all know it's a minimum point? It's not because of this form, but rather, what is the coefficient of x squared over here? It is positive. Therefore, it is a U shape, and the U shape will have a minimum point. Okay, to know whether is it minimum or maximum, it depends on the coefficient of x squared, but to know exactly where the point is, it depends on your completed square form. Okay, so yeah. So we have already learned how to complete the square, but it's important that you know how to deal with completing the square when your x squared coefficient is negative or your coefficient is not 1. So just now the example, I have already showed you how to complete a square when the coefficient is not 1 but a 2 instead. But you just need to make sure you follow the same step process accordingly, and you will get the answer at the end of the day. Okay. So yeah, let's move on. Okay, that was the first method to helping you find the value of the turning point. The second method is to use the line of symmetry. If you are given the line of symmetry, always remember, a quadratic graph is symmetrical about the turning point. It is symmetrical about the line of symmetry. So if you know the if you know the equation of the line of symmetry, you can simply just suck the value of x of the line of symmetry into the equation of the curve, and you can get the y coordinate of the turning point. Can you all see that? You can simply suck the value of the line of symmetry into the curve, and you can get the y value, and then you can get the coordinate of the turning point. Another way to find the turning point, okay, is the midpoint of the x-axis intercepts or the x-intercepts. So because your quadratic curve is always symmetrical, if you can find the intercept over here, okay, you can find the line of symmetry, because the line of symmetry will be right in the middle of the two intercepts. Then when you find of the line of symmetry, same thing. It goes back to method number 2. You just sub it back into the equation of the curve. But this method is not a foolproof method. Why? Because we have learned before, will a curve always cut the x-axis? No. Okay, the curve will not always cut the x-axis. So if a curve doesn't cut the x-axis, then this method won't work already. So how do you find your turning point? You just use your completing the square. Okay, the last method is your differentiation method, which you guys don't need to learn yet. This is a Sec 4 topic. Okay, so make sure you guys know these 3 methods, especially the first one. The first one is the one that you will usually be tested, will usually be used. But why must you know the other 2? It's because the question can insist, find the turning point by using the line of symmetry. Then you no choice. You cannot use the completing the square method. Okay, make sure you know the different methods. So now let's move on to the next page, your quadratic graphs. So this page, I'm not gonna dive into it too much. You guys should know it by now. So you need to know what is the meaning of y-intercept, x-intercept. How do you find them? Y-intercept, right, is on the y-axis. So you sub x equals to 0. A vertical line, the equation is always x equals to something. Then for your x-intercept, your y is equals to 0. A horizontal line, your equation of the curve, okay, is going to be y equals to something, equals to a constant. Okay, someone online asked, can I give an example for example 2? Later we'll be going through some questions, so you can see from there whether that answers your question or not. If not, we can always come up with more questions later to show you guys what I mean by, what I was trying to explain just now. Okay, so x-intercept, y-intercept, please know how to do it. Understand how to find it. Turning point, we have already mentioned just now. Line of symmetry, we have already mentioned just now. Okay, so how do you sketch a quadratic curve? You need to know that because a lot of times there's going to be graph drawing or graph sketching questions. Be very mindful. If your question says sketch in exam, please don't go and do it on a graph paper. Okay, know the difference. Sketch is you can just do it on the full sketch paper. You just draw as accurately as possible. But when you see the keyword draw, okay, it means you need to go and really draw very specifically, very accurately on a graphing paper. There is a difference. If a question is a sketch question and you do it on your graphing paper, you will still get the marks, but you just wasted a lot of time that can be used to do your other questions in exam. Okay, so the first few points we already mentioned just now, identifying the shape, okay, happy face, sad face. Point number 2, okay, y-intercept, we just sub x equals to 0. X-intercept, point number 3, we just sub y equals to 0. fx is basically just equals to y. And then, yeah, turning points we already mentioned just now. Okay, so yeah, we have also mentioned this just now. Now, point number 1, completing the square form. It helps us get the turning point of the graph. How are we going to find, okay, point number 2, going to point number 2 now. How are we going to find the x-intercept of a graph? When you are solving your quadratic equation, do you guys know what you're actually doing when you're solving a quadratic equation? Okay, I see some head shaking. Okay, it's very common. A lot of times when you see a question, the question just say y equals to maybe 2x squared plus 3x minus 5, for example. This is a random question I just threw out. Then the question say, solve the equation. A lot of times, students don't know what they're doing, but they know that they just need to key into the calculator, right? But what does solving an equation means? Solving an equation always means that you are looking at the curve and you're looking where the curve cuts the x-axis. So if your calculator throws out a very weird value, like sometimes you start seeing eyes, right? When you key into your calculator, okay? If you start seeing eyes or something like that, it means that there is no solution. So your quadratic curve actually doesn't cut the x-axis. Every time you are tasked to solve a quadratic equation, you're just basically trying to find where the curve cuts the x-axis. Okay, Solving the equation, okay, solving the equation, solving equation, finding the roots are the same thing. So if the question says, find the root of this equation, it's also simply just asking you to solve the equation. And what does it actually mean? It means that you are looking at the curve, okay, where the curve actually cuts the x-axis. Once you get this idea, you will be able to understand your discriminant concept very well. Your discriminant concept is like your b squared minus 4ac, that concept. Okay? So just tell yourself when you're solving an equation, you're trying to find where the curve cuts the x-axis. How do you solve a quadratic equation? You just key in the equation into the calculator, and we learned 3 different methods, right? Do you all still know the 3 methods? The first method, okay, it's not in the, is it in the notes here? Hold on, let me see. Yeah, it's in the, hold on, sorry, give me a moment. Okay, it's not really exactly in the notes, but how do you solve your quadratic equation? Okay, you all just gotta listen to me verbally explain and take down some notes. There are 3 ways you can solve a quadratic equation. The first thing you guys should always do is take out your best friend, your calculator. Okay, key in your quadratic equation into the calculator. The calculator, if it gives you a very nice answer, it means that you can factorize the quadratic equation, and that is method number 1, factorization. If the calculator gives you a very ugly number, but the number still exists, there are 2 approaches you can use. The first approach is your completing the square. The method of completing the square is exactly the same as before, but okay, you don't just stop at the completing the square form. Okay, you don't just stop at the completing the square form. For example, this is the completing the square form, right? Okay, this is a completed square form. How do you find the intercept, the x-intercept of this curve? You will equate this to 0, okay? And then you will make x the subject. Okay, complete the square and make x the subject. The last method, if your answer is ugly, it is your quadratic formula, which is your x equals to minus b plus minus square root of b squared minus 4ac all over 2a. Okay. Later, okay, I'm not sure if you have heard of this before, but there is a sort of a song that can help you memorize this formula, okay? If you guys cannot memorize the formula, please learn the song. Okay, later I'll go through. It's a bit embarrassing, but I'll go through, okay? So yeah, quadratic formula. So these are the 3 ways you can use to solve for your x-intercept. If your calculator gives you a very weird number, okay, let me try using a calculator right now. Hold on. Okay, why am I using a calculator? I'm trying to find an example whereby there's no solution actually. Okay, there is solution for this. Okay. If I change my quadratic equation to this particular equation, can you all key this into your calculator? Okay, key this into your calculator right now. If you guys don't know how to key into the calculator, let me know. You should, most of you should be using a Casio calculator. You should be going to menu, equation mode, and then select polynomial. Give me a calculator. Okay, you should be, okay, so can y'all key this in? When y'all key this in, do y'all get a very funny value? You guys do, right? You start seeing an I, right? What does this I mean? This I means that your curve doesn't intersect the x-axis. That's why there's no solution. Understand better now? Okay, this is just an example lah. So if there is no x value, right, the calculator show you this I, literally the calculator will show an I, like I for ice cream. Okay, if the calculator show you such a value, it means that you cannot even do these 3 things. These 3 things will not give you an answer because these 3 things are giving you the 3 methods to help you solve for the x-axis. Yes, I means, okay, someone asked, does I mean square root -1? Yes, okay, it is not in your syllabus. I mean square root -1. Okay, sorry, square root -1. But this number doesn't exist in O level. Okay, it doesn't exist in O level. So if you start seeing a I in your calculator, it means that the answer does not exist. You will only learn about this. Last time you will learn in JC lah, but now they remove this in JC. So if you see this, it will be in uni, which is very long to go for most of you here. So don't confuse yourself. If you see an I, just tell yourself that there is no solution. Okay, because someone asked me if I mean square root -1 online. Okay, let's move on to the conditions for positivity and negativity. A lot of times the graph will say, oh, the question will say the graph is always positive, always negative. This concept is linked to your discriminant. When a graph is always positive, it is this one over here. Can you all see that it actually never cuts the x-axis? Because it's always positive, it's always in the positive y-axis. Can you all see that? Because it is always in the positive y-axis, it is literally always positive. But what can you gather from this? Your discriminant, you guys know the concept of discriminant, right? Okay, you guys should know by now. That is your second topic in school. If you know the meaning of discriminant smaller than 0 means that the curve will never cut the x-axis. So for a curve to be always positive, the discriminant will always be negative. This is where a lot of students always make careless mistake, because when they see always positive, then they think that, oh, then the discriminant also means always positive. No, discriminant is always telling you about how many times the curve cuts the x-axis. So if your curve is always positive, it never cuts the x-axis. Therefore, the discriminant is smaller than 0. So similarly, if the question says always negative, your curve is always below the x-axis, right? Therefore, does it ever cut the x-axis? No. So the discriminant is always smaller than 0 as well. Another thing, for a curve to be always positive, do you think it can ever be an N shape? Okay, I see some of you shaking your heads. Yes, very good. For a curve to be always positive, your curve cannot be an N shape. Okay, because if it's an N shape, it will keep extending. Eventually, it will cut into the negative y-axis. Can see that? So for a curve to be always positive, there's actually two conditions. Your discriminant is smaller than 0, and your coefficient of x squared must be positive. This is another very common mistake that is forgotten by a lot of students. When they do an exam question, right, they see, okay, always positive. Then they only care about the discriminant smaller than 0. They forget the fact that actually there's another condition needed. The coefficient of x squared must also be positive. Okay, if anyone is lost, do let me know. If the question says, okay, the curve is always negative, there's two conditions. The b squared minus 4ac must be smaller than 0, and the coefficient of a must be smaller than 0 as well. Okay, must be smaller than 0, because only when it's an N shape, then it will be always negative. If it's a U shape, it will eventually go up, right? And it will cut into the positive y-axis. So how can that be always negative? Not a chance. Okay, so these are your concepts that you need to know for always positivity and negativity. Okay, another thing, it is not in the notes. Okay, is it in the notes? Yeah, it is not really in the notes. Sometimes the exam question can be extra tricky. What they like to do is, instead of saying always positive, they say never negative. Okay, never negative. If they say never negative, a lot of you might be thinking, never negative, isn't it the same thing as always positive? Like, what's the difference? right? Okay, if you guys already can see the difference, great. But never negative and always positive, there is something slightly different. Never negative can also mean this. The curve touches the x-axis because it's just never negative ma. I never say it never cannot be zero. So if the question say never negative, your a must still be bigger than zero, but your b squared minus 4ac is now smaller or equal to zero. Can see the difference? Okay, a lot of school paper, they like to use these never negative words. So now you have learned it, please don't make the mistake in school. Okay, so same thing if I say never positive. Never positive, it will look like this. So your b squared minus 4ac also must include zero. I'm quite sure at least once in your secondary 3 to 4 life, right, you will see such a question. So don't make the mistake. Can, huh? So yeah. So take a look at this question over here. This example over here. The following expression is always positive. Write down a relationship between B and C. Okay, write down a relationship between B and C. Always positive, you need to write the fact that b squared minus 4ac is smaller than zero. So you write that down first and then you sub in the values in and you'll be able to come up with the relationship. Sorry, hold on, let me read a question. Okay, never negative means that your curve looks like this. Okay, someone is asking me about why never negative is b squared minus 4ac is smaller equal to zero. Never negative means that your curve can be positive, can be equal to zero. So does your curve look like this? It does, right? So if your curve look like this, your curve can also look like this. Because, okay, sorry, it's a bit messy. There's not enough space for me to draw. Never negative, your curve can look like this, your curve can look like this. So for this scenario, isn't b squared minus 4ac equals to zero? For this scenario, isn't b squared minus 4ac smaller than zero? The fact that you need to take into account both scenarios will give you this particular inequality. Those of you physically understand, right? You're all like nodding your head. For those of you online, if you don't understand, okay, feel free to ask me at the end of the session. Okay, let's move on to the next page. Okay, common mistakes. Yes, wrong discriminant relation. Okay, yeah, this is a very, very common mistake. The notes even dedicated one page to go through this particular common mistake. So the use of the wrong discriminant relation, yeah, I mentioned just now, when a curve is always positive, student tends to like to think, oh, always positive, so discriminant also positive. No, okay, we have already established just now, always positive, discriminant is smaller than zero. And then the other mistake is the not checking for coefficient of A, which I also mentioned just now. So just take a look at the notes briefly. Yep, I've already mentioned all this just now. Now, let's look at the example. They ask you to find a range of values of k for which the following expression is positive for all real x. This kind of question, right, even though it doesn't look like a always positive question, you need to be able to understand on your own that they're actually telling you that the curve is always positive because they say that for which the following expression is positive. So they're telling you set the scenario whereby the curve is always positive and find the range of values of k. So what you do is you set the b squared minus 4ac smaller than zero. You plug in the coefficients of a, plug in the coefficients of b, plug in the c, and then you will be able to get an inequality and you can start solving for that inequality. Later on, okay, we will go to chapter 2, which teaches you in depth how do you solve this inequality over here. Okay? Okay. So let's go on to equations and inequality. If I'm going too fast, feel free to let me know. Equations and inequality. So actually chapter 1 and chapter 2, you cannot really learn them independently. They're always tested together. That's why you see a lot of chapter 1 question already have chapter 2 knowledge like leaking in already, because it's just like that. They are always being tested concurrently. Okay, let's look at chapter 2. Chapter 2 mainly teaches you on discriminant and also how to solve a quadratic inequality. Previously in Sec 2, you only learn linear inequality, super easy, looks like this. But quadratic inequality is like that. And then they ask you, okay, how are you going to solve for the range of x? You cannot just make x the subject by square rooting both sides. No, okay, please do not do that. This is very wrong. You need to go and use certain tools to help you find the range of x. How do you do this question? Does anyone know how to do this question? Okay, yeah, some of you are pointing in the right direction already. Okay, literally, you need to move the 2 to the other side first. Then after that, this thing over here, even though it doesn't look like it, but you can use your quadratic identity, the third one. Okay, the third one is this one. A square minus b square equals to a plus b bracket a minus b. So you can rewrite this in this form. How do you do that? This is your a square. This is your b square. So how do you do this question? It will be x minus square root 2, x plus square root 2 smaller than 0. Can see that? Okay, then how do you solve for this? Later we'll go through in depth, but you need to draw out the curve and then you need to shake the critical region. Why is the critical region below? Because it's smaller than 0. Okay, and then the two things here will be square root 2 and negative square root 2. How come it's negative square root 2 and square root 2? Because you imagine it's not an equality, it's an inequality. But if you imagine this as an equality, the solution will be square root 2 and negative 2, right? That's why the critical points is at 2 and negative square root 2. Can see that? But you're not solving for an equality, you're solving for inequality. That's why your answer is not x equals to square root 2, comma negative 2. No, this is wrong. It's an inequality. Every time you see an inequality question, your answer is a range. Okay, it's not a specific value, it's a range. So you shade the part where you're interested in, smaller than 0. And actually, your x is smaller than square root 2, bigger than negative square root 2. By default, the more negative number is always on your left. Okay, some schools, they penalize for this. For example, technically, this thing over here is exactly the same as this, right? Like, it's the same meaning. But some schools, they might penalize you for writing this as your final answer because you should be writing from small number to big number. Okay, so please make sure don't lose your marks to presentation. Okay, it's the most stupid mistake, but it's very sad. Okay, please don't do that. Okay, now let's move on to the real notes. Okay, we haven't even looked at the real notes. We're just throwing in some examples over here. So what was I mentioning just now? Remember, every time you're solving a quadratic equation, last time maybe you don't know, in school you just solve it. Okay, I solve it, I get the answer, that's it. But now you should know already, when you're solving a quadratic equation, you're finding where the curve cuts the x-axis. And the place where it cuts is called the roots, which is mentioned over here. The roots of the quadratic equation, actually it's here. Just now I already mentioned. Okay, the roots of the quadratic equation, you have 3 different ways to find it. This is provided the roots exist. If the roots don't exist, you cannot even use all these 3 methods. Okay, just now remember I mentioned 3 methods: factorization, quadratic formula, and completing the square. Factorization method, I think I don't need to teach, right? Most of you should know this in Sec 2. Okay, but important thing is I know, okay, even my students, a lot of them, they don't like to draw the factorization table at the side. Okay, different schools have different factorization table. For example, mine is, I like to use this one. Okay, if you know this, you know this. Some school, they teach the box method. Okay, it's okay. Like whichever method is fine. But the important thing is you put it in your exam script. You don't just key into your calculator and then, for example, just an example. Okay, this is a very simple one. For example, this. You key into your calculator, it's going to be x minus 1. I mean, the calculator will throw you out a 1. Only one value some more. So you know that this is happening. But from here to here, you can get it from the calculator, but you should still show the factorization table at the side. Some schools, they don't emphasize that you need the factorization table, but I can tell you, O-levels, they look out for it. Cambridge examiner already say, how come they don't see this? Then they go and deduct marks. So please, if you know how to do this, this factorization table, please include it in your working as a form of good practice, because in O-levels, you should have it. Okay, so include your factorization table. Then this one is you get from the calculator, but technically the calculator tells you this, x is equals to 1. So this is the factorization method. Quadratic formula is another method, is when your factorization method doesn't work. When your answer is very ugly from the calculator, you know that, okay, factorization method is out. I should be using quadratic formula or completing the square. Okay, does anyone over here know how to memorize this formula easily? Okay, I know some of you do. Okay, my students, they will already know how to solve this, remember this formula easily. Okay, some of you might have learned it in school, especially if you're from Nanyang Girls High. Okay, you will also learn this tune to help you memorize the formula. Some school teachers might also teach, okay? So if you cannot remember this formula, which you have to, because it's not provided in your formula sheet, right? Is it provided in your formula sheet? Oh, it is. Okay, if it's provided in the formula sheet, great. But if it's not provided in the formula sheet, you have to memorize it. And you can remember it using the, wow, what song is that? I think it's Mary Had a Little Lamb, okay? You remember it using Mary Had a Little Lamb tune. It's very embarrassing, okay? But I'm going to sing it for you guys. Okay, just a one-time thing. So you remember it as x equals to minus b plus minus square root of b squared minus 4ac all over 2a. Okay, y'all hear the song once already. I don't think y'all will ever forget this formula. It's so cringe that you're forced to remember it, okay? So please, if you have ever forgotten this formula, please sing this tune in your head. I'm not gonna re-sing it again. It's very awkward over here, 12 of you, 11 of you staring at me, or 10, okay? But yeah, if you ever forget this formula, please sing this song to yourself, go and practice it at home until you can remember the formula. It's very important for you to know this formula, because if you don't know this formula, you won't be able to go and find the answer for the quadratic curve, the roots, without giving the proper working. If your factorization method fails, you only have quadratic formula and completing the square to rely on. And sometimes the question can pinpoint exactly. They say, solve the quadratic equation by using the quadratic formula. So you have no choice. Even if the question you can factorize, but the question already say, I want you to use quadratic formula. You also have to use quadratic formula, no choice. Okay, so please remember this formula, it's very important. The last one is you're completing the square, which we already mentioned just now. Okay, completing the square, just complete the square, but you're not done. After you complete the square, you must equate it to 0 and make x the subject. And then you can find the roots of the equation. Same thing, ask yourself, what does roots of the equation mean? Okay, now let's move on to the next page. Nature of the roots of the quadratic equation. So previously, we have learned the formula, the quadratic formula. Okay, we have learned this. This formula inside actually contains something called a discriminant. Previously in school, you might have already learned what does a discriminant mean. Okay, the discriminant smaller than 0 means no real roots. Discriminant bigger than 0 means 2 real and distinct roots. Discriminant equal to 0 means 2 real roots, 2 real and equal roots. You learn this, but you might not know the reason behind it. The reason behind it is because this is your quadratic formula. Can you ever square root a negative number? You can't, right? Key into your calculator. If you square root a negative number, your calculator will give you error. Okay, it gives you an error, right? See error 2 or just an error? Error, a math error. Okay, yeah. If you use a sharp calculator, you'll probably throw out an error 2. So if you key in a negative number, a square root, sorry, let me rephrase it. If you key in a square root negative number, you will get an error. And because you get an error, right, do you think your x exists? No, your x doesn't exist. So this formula explains to you why the discriminant concept is true. The fact that you square root a negative number, right, and it gives you no solution, inside the square root, if it's smaller than 0, it will give you no solution. Can see that? See how it's linked? Okay. The fact that if your inside is equals to 0, you plus minus 0. Technically, you only have one answer, right? Because you plus minus nothing. That's why it is only one root. I mean, you only have one value for your root. Therefore, it is 2 real and equal roots. It looks like there is only one root, but you cannot say it's one root. The idea is the curve touches the x-axis once, okay? It touches the x-axis once, but you cannot say one root. You must just tell yourself it's 2 real and equal roots. There's no such thing as one root. 2 real and equal roots is the same thing as touch x-axis once. Don't say one root, no such thing. Why is it no such thing? Why is there no such thing as one root? It's because a quadratic equation by right should always either have no roots or 2 roots. Why 2 roots? Because literally power 2 is telling you that, you know, there's going to be 2 roots if there are roots. So every time when you have your b squared minus 4ac equals to 0, tell yourself it is 2 real and equal roots, even though the curve touches the x-axis once. Then this one, okay, coming to the 2 real and distinct roots, real means it exists lah. Okay, the meaning real, the meaning of the word real means that something exists. So it exists because inside your square root is not a negative number. And the fact that, you know, if there's a value in here, you have a plus minus of the value, maybe square root 2. Okay, so you will naturally get 2 solutions. Therefore, it is 2 real and the 2 solutions are distinct, they are different. So this is the explanation behind why your discriminant formula works. Last time, maybe you learn, okay, discriminant, you know, bigger than 0 is 2 real and distinct roots. But now you learn why is 2 real and distinct roots. Can see that? Okay, so yeah, 2 real and distinct roots, your curve will look like this or this. Okay, for those that just joined online and are asking for notes, let me resend the link. So access this link and download session 1. Okay. So these are your 2 real and distinct roots, and how your curve will look like when it's 2 real and equal roots, it will look like this. You see, we can see that there's only one intersection, but you cannot say that it is one root. You must say it is 2 real and it is 2 real and equal roots. Okay. And then the last one is no real roots, discriminant less than 0. So it can look like this. Yes, distinct means, okay, someone online asked, so does distinct means different? Yes, distinct just means that you have 2 roots and the 2 roots appear at 2 different points. Okay, intersect twice at 2 different points. 1 point, 2 point. 1 point, 2 point. Okay, someone asked, will the solutions be uploaded into the Telegram channel? Okay, I'm assuming you're asking for the solutions to the supplementary question. That I cannot confirm with you yet, but you can definitely keep a lookout on the Telegram channel whether we upload the solutions or not. Because honestly, these questions are all school exam papers, and we ourselves, we do not have answer key to them. So we actually have to come up with their own solutions. So if we manage to come up with all the solutions in time, we might post it onto the Telegram group. But today I will go through some questions. So for those questions that I'm going through, feel free to take a screenshot of the solutions if you don't have time to copy them. The recording will also be uploaded. Okay, yeah, so let's take a look here. If the question say real roots, okay, the question just say, oh, real roots exist for this quadratic equation, your b square minus 4ac is bigger and equal to 0. Because the question never tell you whether is it real or distinct. They never tell you whether is it real or equal. They only tell you that roots exist. So you need to take into account both scenarios. B square minus 4ac is bigger and equal to 0. Okay, so just take a look, read this on your own. Okay, let's move on to the next page. Okay, for discriminant questions, what I like to tell my students is there's mainly only 2 types of question. Once you get the hang of it, right? Like you get the hang of this chapter and you realize that there's only these 2 types of question, you will be able to do every single discriminant type questions. You need to be able to identify that it is always either going to be a proof or show question or a set question. They are very different, okay? The way the question is being phrased will affect your presentation. If it's a set question and you use a show question working, you will not get the full marks even if your answer is correct. So please be very mindful. Okay, let me go through what do I mean by proof and set questions. But in generally, it means that if the question is being phrased like that, okay, you all got to listen to me concentrate on what I'm trying to say verbally. If the question says, okay, this curve cuts the x-axis at 2 points, then they ask you to maybe find the range of this particular constant. The fact that the question already tell you that the curve cuts the x-axis at 2 points, it means that it is a set question. The question is already telling you that the b square minus 4ac will be bigger than 0. This is a set question. Later we'll see examples, but I'm just trying to explain verbally right now. A proof question will sound something or look something like this. They will say that, oh, given that this is the equation of the curve, I determine how many times the curve cuts the x-axis. Now the question did not tell you how many times it cuts, right? You have to go and identify on your own. So how do you identify how many times a quadratic curve cuts the x-axis? Okay, it's going to be using your discriminant. If your discriminant is bigger than 0, it cuts the x-axis twice, equal to 0, 1, smaller than 0, 0. Okay, it doesn't cut. So this kind of question is, there is no scenario being set. You yourself need to prove what does b square minus 4ac is. What is the value? You need to prove it. So this is your show question, your proof question. Okay, these are the main 2 types of question. Once you understand the two different types of question, I guarantee you this kind of question will be super easy already. Okay, so over here, this is a show question. The question says, the following has real and show that the following has real and distinct roots. So can you see the goal that you need to do? I mean, the main thing you need to do, your goal is to show that the discriminant is bigger than 0. It is different from setting the discriminant equal to bigger than 0 and solving the question from there. And this kind of show question, right? Usually the last step, it will end off with a completing the square. Take a look at this question. Okay, you need to show that the following has real and distinct roots. Naturally, you will start to think of your discriminant, right? Because it's a quadratic curve, you should bring in your discriminant concept. You want to show that the b square minus 4ac equals to 0. So you start subbing in your b, you start subbing in your a and your c into the b square minus 4ac. And you get something like this, okay? You get something like this, and then you are like, I get this ready, but how am I going to show that it's bigger than 0? How am I going to, is there any questions? Okay, how am I going to show that this is bigger than 0? Like, what should I do? You should start thinking of your completing the square. Okay, you might be thinking, okay, so I bring in completing the square. That's what I always do in school. But now I'll explain why you need to bring in completing the square. Because when you bring in completing the square, a square term, can you see, is always going to be positive? If a square term is always positive, okay, a square term is always positive, and you add something that it is positive as well, can you see this whole thing will always be positive? Sorry, a square term is not always positive. Let me rephrase. A square term is always bigger or equal to 0. bigger or equal to 0. So if this thing is bigger and equal to 0, and you're adding something that is bigger than 0, can you see this whole thing will naturally be positive? And therefore you can show that b squared minus 4ac is positive. Same thing, if you want to show that b squared minus 4ac is negative, you should also do completing the square. Why? Because yes, this term is always positive, but is it also right to say that this thing is always negative? So if I have not always negative, it's always negative and equal to 0. If you have something that is always negative and equal to 0, and you minus another number, isn't it right that to say that this thing will always be negative? So this is the reason why every time when you are trying to prove that something is always negative or always positive, you should start thinking of maybe I want to bring in completing the square concept. Okay? So you complete the square to get something that is always positive or always negative. And then you can see that, okay, this portion will always be bigger and equal to 0. And if there's an 8 in front, it will still be always and bigger equals to 0. Therefore, even after you plus something, it will definitely be bigger than 0 lah. So your b squared minus 4ac is going to be always bigger than 0. Okay, hence the function has real and distinct roots. Okay, and what we have just went through is a show question. Later, if we have time, I hope that we have time, we'll go through a set type of question. Okay. So now let's look at lines and a curve. So previously we have been looking at a curve, how many times it intersects a x-axis. But now we are looking at a curve, how many times it intersects a straight line. This line is no longer an x-axis, it can be any linear line. Okay, so how do we identify how many times the curve cut the line? The first thing we always need to do is we just equate the curve to the line. Okay, we just equate the curve to the line. Hold on. So, okay, let me go through this page first. Go to page 18. So if we want to show that a line meets the curve at two distinct points, the first thing we do is we always equate the line in question and the curve together. After we equate them, we make one side equals to 0. Then isn't this very familiar already? It's the same thing as what we have done previously. Okay, we just identify the discriminant from this particular equation. Why do we need to equate the curve together? And why do we need to make one side equals to 0? Because previously, right, we learned that, okay, we are actually looking at the equation of the curve with respect to the x-axis. But the x-axis, can you see, is actually equation y equals to 0? So what you're doing here is you're transforming a line and a curve. You're somehow adjusting it and you're making it into a curve and the x-axis instead. That's why you must equate them together first and make one side equals to 0. After that, it is exactly the same as the previous steps already. You equate to 0, you get your A, you get your B, you get your C, and then you plug in into your discriminant formula. Okay, can see the difference? Just now, our example was a curve with an x-axis, but now this example is a curve with a random linear line. But what do? We equate the curve and the linear line first. Then we make one side equals to 0. Why we make one side equals to 0 is to sort of kind of squeeze out the x-axis so that in a way the concept becomes the same already. You're looking at a curve with respect to the x-axis. Okay? This question, same thing. What kind of question is it? It's a show question. So you cannot set the discriminant. You need to prove that the discriminant value is bigger than 0. So after you sub everything in, okay, you want to go and complete the square again. Because when you complete the square, you can force out a positive term at the end of the day. Can see that? Okay, let's come back to the previous page. So these are the page to show you the different scenarios. When a curve and a line cuts at 2 points, it will look like this. This is not exhaustive. It can look like this as well. It can look like this as well, up to you. Okay, but basically cut at 2 real and distinct points. Okay, it is not very good to say two real and distinct roots lah, because roots is talking with respect to the x-axis, but the idea is because when you transform this, okay, the idea is you're transforming this into this scenario again. That's why you use that's why the notes can use the word roots over here, because you're transforming the scenario from this back to the curve with respect to the x-axis. And then here is the same thing, tangential. Okay, when you see the word or when you hear the word tangential, it just simply means the curve touched the line once, two real and equal roots. Okay, and then the does not intersect. Same thing, the curve and the line doesn't intersect. Okay. So yeah, if the question says intersect, same thing. Previously, just now was there's real roots, right? Then b squared minus 4ac bigger equal to 0. So if the question just said the curve and the line intersects, so that means if you equate them together, the b squared minus 4ac will be bigger equal to 0. It's exactly the same thing. Okay. So yeah, we have went through this already. And now we are looking at quadratic inequalities. Okay, so this page, read it up on your own. There's nothing too special about this. Okay, just read it up on your own. But this is what you have already learned for linear inequalities in Sec 2. So how do you solve for quadratic inequality? Actually, just now we briefly mentioned already. Okay, so the most important thing is you must tell yourself, you cannot just square root the question. You need to treat it like a quadratic equation, but at the end of the day, you tell yourself you are not solving for an equation, you are solving for inequality. So you treat it as an equation, but after that, you need to have a critical region to identify where is your inequality that you're interested in. Okay, so this part, okay, what this part is trying to tell you that typically if you see a negative, negative sign in front of your x squared, you can leave the negative there. There's nothing wrong with it. But it might be better if you multiply the whole thing by -1 to make your life easier so that you are dealing with a U-shaped curve instead. A U-shaped curve is just sort of easier to deal with than an N-shaped curve. Okay? Okay, so this one I will use an example to go through what's happening. Okay, there's no example. But how do you, like just now already use that one particular example? Hold on, do I still have it? Yeah, this one over here. So if I'm given this inequality, I ask you to find the values of x. Tell yourself, if you are solving for a quadratic inequality, your answer is always a range. So if you get one specific answer, definitely your answer is wrong. You need to check your work. How do you do that? Okay, I mean, how do you move on from here? Okay, let's use another example. Maybe something like this. Hold on. I'm using like super easy examples. Give me a moment. Can this work? This should work. Sorry, give me a moment. I'm trying to come up with examples for us to do. Okay, yeah. Okay, if the question is something like this, smaller than 0, how would you do it? How would you solve this quadratic inequality? First thing you do is, okay, you realize it's a quadratic equation, you should key into your calculator. I mean, it's not a quadratic equation, it's a quadratic inequality, but you should treat it like an equation first. So when you key into your calculator, you will get -3 and 1. Do you get -3 and 1? Yes. So what does it mean? You reverse the calculator answer and get your factorized form. After this, okay, you tell yourself you have to treat it like an inequality question already. So what you do is, this is a what shaped curve? It is a U-shaped curve. So you draw a U shape first. If you have a negative sign in front, then you have to draw an N shape. But remember just now that notes that we met, what was it trying to say? Usually you want to deal with a U-shaped curve. You make sure that your coefficient of x squared is positive. So you deal with a U-shaped curve and then you draw your line. What does this line mean? This line is actually your x-axis, okay? Because your x-axis is where y equals to 0. And you're interested when the curve is below y equals to 0. Can see that? So you shade here. Then what are these 2 points? These are the 2 points when you treat it like a equation like that. So you know that this is going to be 1, this is going to be -3. So what is your inequality here? It is actually x smaller than 1, bigger than -3. So this is how you deal with a quadratic inequality. If the question changes, and now I'm interested in the portion where the curve is bigger than 0. So now my critical region is on top. Can see that? And now my solution will be x smaller than -3 or x bigger than 1. Make sure you are using the correct keyword. You are using the keyword or. Do not use and. Okay? What does or and and means? Or means that this can happen or this can happen. I will get the answer. If you use the word and, it means that this must happen together with this. But is that graphically even possible? No way, right? There is no intersection with this area at all. So how can these two happen together? They are happening separately and they both make sense. Therefore, you need to use the word or. Can see that? Okay, if you can see that, let's move on with our notes. Okay. Okay, someone asked if one part of the question asked to sketch the graph, they will accept a U-shaped graph as the answer if it was originally supposed to be an N-shaped graph? No, okay? So if there is a question that asks you to draw the graph specifically, you cannot go and change the graph shape on your own. Why can we change the graph shape here? It's because it is not a sketching question. When we are changing the graph shape here, the solution, okay, the range of x that we get will still be the same. But if it's a graph sketching question, they already want you to draw a U-shaped graph, for example, and you go and just randomly put in a negative sign and change it to an N-shaped graph. You're not answering the question already. Why can we remove the negative sign here? Is because if we have the negative sign here, the answer that we get at the end of the day will still be the same. It will be adjusted accordingly. Okay. Okay, I'm sorry, I don't understand what your question means. If no range, just solve normally, right? If you can rephrase that for me, that would be great. Okay, will marks be deducted if you don't draw the critical part? Not really. Marks, this thing over here, there is no marks given, but I would advise you guys don't be lazy and just draw it out. Because if you don't draw it out, you might make careless mistake on which region you're supposed to look at. And it's not that difficult lah. This one, 2 seconds only, okay? Just draw it. Okay, let's look at the notes. Let's go back to the notes. Okay, unfortunately, because we don't really have a lot of time left, I will only go through the questions later, or I can flash it to you guys later and you all can take a screenshot, but I will continue with the concept first. Okay, I will go on to exponential and logarithms. Yeah, sorry if I'm rushing a little because we are running out of time. Okay, so this particular chapter, okay, just be mindful. Your exponential, every time when you see an exponential equation, an exponential question or a logarithm question, there are 2 chapters that might, come in along the way, and it will be your indices and surds, and also sometimes your simultaneous equation. So what am I trying to say here is, I'm just trying to tell you that most of the time, right, when you see this kind of question, don't be, flustered if you realize that, actually I need to bring in indices, surds, I need to bring in simultaneous. Oh, there's one more, your quadratic equation. This one is a fan favorite for schools. Like they like to bring in quadratic equations when there is an exponential equation given. Okay, we will go through an example on that if we have the time. Hold on, I have more questions coming in. Okay, sorry, we don't have enough time, so I'll go through after the session. Okay, just remind me, so save your questions and ask me later. Your exponential function, this is how it looks like. Be careful. A lot of students think that this is the only exponential function. No, okay, this is not the only one. Anything with x in your power, it is considered an exponential function. Okay, and sorry, your base must be a constant number. This is an exponential function. This is an exponential function. This is an exponential function. Okay, it's not only this, because a lot of students think, oh, e for exponential, so only e power x is an exponential function. No, okay, there are many different types of exponential function. It's just that e is a common base, okay, and if your base is 10, that is your e is a natural base. It is just, I meant to say it appears commonly. If your base is a 10, this is called your common base. This is your natural base. Do you all know what is the meaning of base? Okay, if you don't know what's the meaning of base, you have to know, okay? So when you have something like this, the big number literally sitting on the straight line, okay, is called your base. The thing floating on top on the right, that is called your power, your exponent. So in school, your teacher will probably keep saying, oh, the base is 10, the exponent is 12 or something like that. You need to understand what your teacher is trying to tell you in school. That's why you need to know what number, what is the name, okay? So yeah, okay, and here we are looking at the graph shape first. You need to know the graph shape for two reasons, okay, written here. Why do you need to know them? Is because a lot of times the question will ask you to sketch the graph out. So that is one reason why you need to know the graph shape. Another reason you need to know the graph shape is to help you reject or accept answers. Okay, for most of you here, if not all of you, definitely already learned this in school. Okay, you have already learned this chapter in school, and you would realize that especially when you're dealing with a log question, there are times you need to reject answers. And how do you know you need to reject the answer? It can be explained using the graph shape. Okay, so now let's look at the graph. Your exponential graph looks like this. Okay, this is your exponential graph. If there is a negative sign in front of the x, the graph will flip about the y-axis. Okay, if there is a negative sign in front of the x, it will flip about the y-axis. Why am I going through this? Because the question can say, sketch y equals to negative x plus 1. So the only thing you really need to remember is y equals to ex. Okay, you just need to remember this one and it will look like this. Okay, and then if you see a negative, then you just tell yourself, oh, the graph just flip about the y-axis. If there is a negative sign in front of the e, okay, or technically, actually, if there is a negative sign in front of the y, which it becomes this. If there is a negative sign in front of the y, the graph will flip about the the x-axis. Okay, it will flip like that. Okay. So what am I trying to say here is, so long as you remember this one, you can remember all the different permutations. Because if you see a negative sign in front of the x, you flip it around the y-axis. If you see a negative sign in front of the y, you flip it about the x-axis. Make your life easy. Don't go and remember all four graphs. Remember one and derive the others from there. Okay, so this one, there is two negative signs, right? So you tell yourself, is flip about the y-axis and then flip about the x-axis. That's why naturally, at the end of the day, you will end up with a graph like this. The dotted lines is not because it's correct to leave it and dotted. No. Why we put dotted lines in the notes is because you are trying to show you that there are two different lines. But when you are drawing the curve for exam, right, please don't use dotted lines. Dotted lines are only reserved for asymptotes. Okay, so please make sure you are using like bolded lines. Yes, this will be commonly tested. Graph drawing is a very commonly tested question. Even if it doesn't appear in maybe your end of year, expect it to appear in maybe your next year mid-year. Okay, it's a very common exam question. So the asymptote, okay, another thing, you need to know the asymptote of the graph. The asymptote for y equals to ex is y equals to 0. What does asymptote means? Asymptote means the graph tend towards the value, but it never reaches. Okay, so by right, here there should be a dotted line, y equals to 0, to show that, okay, the graph tends towards it, but it never cuts it, it never touches it. You need to know the asymptote because this is how you start rejecting values. For example, you have this graph and suddenly your y equals to -1. Do you think that makes sense? No, because this graph, right, it will never even go below y equals to 0. So if you start getting a value like this, you should already tell yourself, I need to reject this answer, or maybe I'm not doing the question right. That's how you check your answer. How do you check whether you're on the right track? Okay. How do you determine the asymptote? Question from online. You just need to memorize for now. Okay, you just need to tell yourself, if your curve is this, the asymptote will be y equals to 0. Then as the curve rotates, as the curve flips, or as the curve shifts up, shifts down, which we will go through later, the asymptote will change accordingly. So let's look at vertical translation first. Vertical translation means your graph is shifting up, shifting down. How does it shift up? Is when there is an addition of value, okay, that is not inside the x, okay? There's an addition of value outside. So if it's a plus b, naturally your curve will shift up by b units. Can see that? So if it shift up by b units, your asymptote, right, will be now y equals to b. Okay, then same thing. If there's a minus b, that means the curve will shift down, and then your asymptote is now -b. This is your vertical translation. If there is a horizontal translation, it means your curve shift left or right. Okay, this one is a bit trickier, okay? Because if it's an addition, okay, the horizontal translation is when the value is being added with your x. This one, the value is being added outside the ex term. Can see that? Whereas this one, the value is being added with the x in the exponent. If it's added with the x, okay, if it's an add, if it's an addition, it's slightly counterintuitive. You are actually not moving towards the right, but you're rather moving towards the left. Okay, but can you see that the asymptote doesn't change because you're not shifting up or down at all? Okay, the asymptote remains the same as y equals to 0, but your curve is being shifted to the left if it's a plus. If it's a minus, your curve is being shifted to the right. Okay, what is the meaning of an asymptote? An asymptote is the line where the curve will never touch. So your y, let me redraw this. Your y equals to e to the power of x will never cut. It will never cut your x-axis. Therefore, your x-axis is the asymptote. It just tends towards it. It will never cut it. Okay, this asymptote logic is especially important when you are looking at your log graph. A lot of times, I'm sure you have come across log graph drawing in school. You are expected to sketch your asymptote along with your log graph. Okay, so someone asks, so an exponential curve can be one curve or two curves. Exponential curve is just one curve, okay? It's just one curve over here. If there's two curves, because these are two different curves with two different equations, okay? One equation will give you one curve. One equation will not give you more than a curve. Okay, let's move on to the logarithmic function. This is the very important sketching question. Okay, a lot of times the question will ask you to, first part, sketch a log graph. Same thing, your log graph can reflect about the y-axis and also can reflect about the x-axis. So just now remember, for exponential graph, how does it reflect about the y-axis? Okay, how does it reflect about the y-axis? Is when there is a negative sign in front of the x, right? Okay, so same logic here. If there's the negative sign in front of your x, your graph will flip about the x-axis. Why is there a negative sign? Because your b from positive become negative. So the negative sign is in front of your x. Okay, if anyone is confused, this is how your typical log graph look like. Same thing, there is a asymptote. Okay, let this be maybe log, let me set it as base 10. Okay, the asymptote is at x equals to 0. Okay, sorry, let me just check something. Yeah, the asymptote is at x equals to 0. So if there is a negative sign in front, it will flip about the y-axis. Okay, someone says, not exposed to such translated questions. Okay, so some of you might be concerned that this is not in syllabus. You might have realized that reflection is actually is a JC topic, but what I'm teaching here is definitely in your syllabus. Okay, why do you need to know all this? Because the graph question can say, okay, some of you are concerned, why do you need to know this? The question can ask you to sketch this, but the question can also ask you to sketch this instead. The question can also ask you to sketch this instead. So how do you know how these two look like? It's because you know that if there is a negative sign, it will flip about the x-axis in front. If there is a negative sign with the x, it will flip about the y-axis. If you don't know how it flips, you will not even be able to sketch out the graph general shape to begin with. Can see that? So you need to know how it flips to know the general shape. Then you can do your graph sketching question. Okay. So same thing, if there is a negative sign in front of your x, it flips about the y-axis. Then if there is a negative sign in front of your y, over here, it flips about the x-axis. Okay, so yeah, everything is color-coded. How do you identify the asymptote of a logarithm graph? Oops. Okay, for example, you key into your calculator, log 0, LG0, you will get an error, right? You key in ln 0, you will also get an error, right? Okay, what does this error mean? This error is actually where your asymptote is at. Because remember, your graph will never touch the asymptote. So it means that there is no such value as log 0. Okay, there is no such value as log 0. It doesn't exist. And log 0, what is the value of x? The value of x is 0. Can see that? That's why your asymptote is equals to x equals to, the equation of the asymptote is x equals to 0. How do you find the equation of an asymptote is, you set this value equals to 0 and you can find the equation of an asymptote. For example, this particular graph, if I want you to sketch it, first of all, you need to know the general shape. Let me restart. You need to know the general shape. The general shape is going to be something like this. Is there a negative sign in front of my x? No. Is there a negative sign in front of my y? Don't have, right? So do you think there's any reflection involved? Don't have, right? So there's no reflection involved. So this is how the graph will look like generally. The next thing you need to do is identify where is the asymptote. How to identify the asymptote? You equate this equals to 0 and solve for x. So if you make 2x minus 1 equals to 0, okay, x is actually equals to half. Can see that? So your asymptote, you must draw in dotted lines, and your curve cannot cut it, is at x equals to half. Can see that? So this is how you sketch the curve. And you're not done, because a curve sketching question always need your intersection point. So what you need to do is you need to identify this point and go and mark out the exact value. It's going to be easy to identify this point. Why? This point, y is equals to 0. Can see that? So you just let log 2x minus 1 equals to 0. Then use your logarithm to go and solve for the value of x. Can see that? So it will be 2x minus 1. You 10 both sides. Because if you 10 both sides, right, your log will disappear. Can see that? You 10 both sides. And then after that, it will be 10 to the power of 0, which is equals to 1. Okay, so 2x is actually equals to 2. And x is equals to 1. So this point over here is 1, 0. Can see that? Sketching question, first of all, you need to know the graph shape. You need to put in the asymptote, and then if there's any intersection, you need to go and mark it out. Can see? So this is why you need to know the reflection. If I change the question, I simply put a negative sign in front like this. You know that the curve flips about the x-axis. So it will just look like this instead. Because it just simply flips, right? Oops, sorry. It simply flips. So your curve will look like this instead. Can see that? Okay, so that's most of it about the graph questions. So these two are slightly trickier, especially the horizontal translation part, but you still need to know this. So make sure you understand the gist of it so that you'll be able to get the graph shape accordingly. So if you add in your x, remember, if it's an addition, it's actually moving towards the left-hand side. If it's a subtraction, it is moving towards the right-hand side. This one is just something you need to take note of. Okay, and your relationship between a logarithmic and your exponential function graph. There's a typo over here, so please change it. Okay, your note should say a E, but it shouldn't be a E, it should be a A. Your exponential graph and your log graph, okay, your exponential graph and your log graph must be always symmetrical about the line y equals to x. But these two graphs what must they have in common? They must have the same base. So if I change this to a ex, then this one will be y equals to ln x. So this symmetrical relationship only applies when the base is equal. So you cannot say that y equals to maybe kx is symmetrical to y equals to log 10x. Cannot, because this one the base is 10, this one the base is k. Can see that? Why do you need to know this? Because sometimes they might ask you to, can you identify the equation of the exponential curve that is, a reflection about this log curve about the line y equals to x, something like that. So you need to know this relationship because they can test you a lot of things, anything using this relationship over here. Okay, so this one you can read it on your own. This one you just read it on your own, but it's basically trying to tell you that, an asymptote exists. When an asymptote exists, it means that there is an undefined value. Okay, so yeah, let's move on to the laws of logarithm. So laws of logarithm, the most important thing when you're doing a log question that deals with laws of logarithm, the most important thing is you do not ever create your own log rules. This is the most common mistake. Once you start creating your own log rules, your whole question is gone. No such thing as working marks, no such thing as PT marks. Your whole question is gone. What do you mean by do not create your own rules? It means that, for example, this is your addition rule, right? But suddenly you go and write this one fine day. You are already creating your own rule. You are not following the rules. You are just randomly trying to do the question because you feel stuck somehow. Once you start writing a rule that doesn't make sense, that doesn't follow the laws of logarithm, it is instantly wrong. And this is a very common mistake. Why do students make this mistake? It's because they cannot remember the log rules. Okay, they cannot remember the log law. So what do you need to do? You tell yourself, you just have to remember this. You just have to memorize this by heart. Okay, with a lot of practice, this is very easy. Addition rule is saying that if you have two log terms with the same base, must be same base, you can combine them together by multiplying the big number over here. Can see that? Subtraction rule, same thing. Make sure they must have the same base. If they don't have same base, you cannot even combine them. So you can combine the big numbers by doing a division. This one is very straightforward and you should remember. Power law is simply just saying if there is a power that belongs to the entire big number, the entire thing, you can drop the power down. Okay, this is very different from this. For example, UN, never mind. Let me write KUN. This is false. Okay, this is false. Why is this false? Because your N only belongs to the U. Can see that? Your N needs to belong to the entire thing. Then you can drop the power down. So this is another very common mistake. Please make sure you don't make this a mistake. Don't go and push the power down when the power doesn't belong to the entire term over here. So this is your power law. And then you have your same base law. When your base is equals to the big number, it is just equals to 1. This one you can always use your calculator to check. You key into your calculator ln e, or you key into your calculator log 10, you will always get a 1. And this is how you can help you memorize this formula. Can see that? Okay, there's a formula that's important that is missing here. Oh, sorry, let me mention this first. Okay, sometimes in the question, if you see a 1, you see a log question, you see a number 1, maybe you want to change it to a log instead. So maybe the question cannot be done if you leave it as a 1. If you see maybe the question looks like this, log 7, log k plus 1 equals to maybe log 7, 8, something like that. When you see this kind of question, this 1 over here, it might be better if you don't leave it as a 1, but instead convert it to a log. So it will be plus log 7, 7 equals to log 7, 8. Can you see that? And then now, can you solve for k? Yes, you can solve for k because you can use your addition formula here. And technically, 7k equals to 8. K equals to 8 over 7. Can see that? So what am I trying to emphasize here? I'm trying to emphasize that if you see a number 1, don't be too happy. Okay, it doesn't mean that, wow, 1 is a very nice number, I leave it as a 1. No, sometimes you might have to convert it into a log to help you do your question. Can see that? There might be more than one ways to do it, but this is a way to consider doing the question. Okay, now another formula that is missing here is your base 1. Anything with a base 1 will give you 0. How do you remember this? Your log form, right, is actually a rewritten version of your exponential form. What do I mean by that? 10 to the power of x equals to 8 is exactly the same as log 10a equals to x. This is your exponential form. This is your log form. It's just, they are exactly the same thing, but they are just being rearranged. So why does this happen? Because if you convert this to exponential form, it will be, did I write something wrongly here? Give me a moment. It's correct. A to the power of 0 is equals to 1. Anything to the power of 0, you can try on your calculator, it will be equals to a 1. So if you cannot remember this instead, and then you convert it into your log form. This is an exponential form, this is a log form. Can see? Okay, and then the next important formula is your change of base. This one is very, very important. These two are the same thing, but focus on this one. Okay, this is very important. Every time when you see a log question, if you see more than one base, immediately it's confirmed you need to use change of base as you're working. Okay, and it should be your first few steps. How to change your base? You choose a new base that you're interested in, and the big number is in the numerator. And then same thing, your denominator should also contain the new base you're interested in, and the original base will be the denominator's big number over here. Okay, and then your change form, which is exactly already what I mentioned. This is your log form, this is your exponential form. They are the same thing actually, it's just being rewritten. Okay, so yeah, common mistake. It is simply just the same thing as I mentioned just now. Do not create your own log laws. Once you create your own log law, the whole question is gone. Okay, common types of question in your logarithm chapter. Okay, or your, sorry, not just logarithm chapter, your exponential and logarithm chapter contains substitution, solving for variables, that means solving for your x, solving for your y, and application question. I'm sure you have come across the application question before. Usually they like to use bacteria, virus spreading, or like, oxygen depleting, that kind of thing, or water refilling. So your application question is pretty straightforward, but the trickiest part is the context, because how you get your answer, okay, usually when you deal with your log
your log questions, you don't get an exact answer, right? There's decimal place, right? Because your log function will give you some decimal place, it will involve some decimal place in your final answer. But for a log and exponent application question, your rounding off is not just round up or down. You need to understand the context, then you know whether is it truly round up or down or not. Same thing, I will use an example to go through this. Okay, and I also will talk about what is a substitution question, what is a substitution question, which we'll be doing right now. Okay, oh sorry, one more thing. Okay, this one is important. So this is a type of question that will also keep appearing. Your question that has multiple base. So what do I mean by multiple base? Take a look at this question. Can you see that there are multiple base appearing? The first thing you need to do immediately when you see so many different bases, right, is to do your change of base. Okay, it's very obvious. You just tell yourself, so many different base, just change your base. What do you need to do? Like, oh, but there's so many different base. Which base should I choose? Okay, this is not in your notes. Which base should I choose? This is a formula that I like to tell my students. Your ideal is you want everything to have the common base. So you need to bring in the change of base law. You choose the most convenient number that has already appeared. Okay, in this question, the most convenient number is definitely not square root 3. Why would you deal with a square root 3, right? So you're left with 3 or 9. You don't want to bring in another number that has not appeared before, right? But 3 and 9, which one is more convenient? Do you realize that 9, you can rewrite it to 3 to the power of 2? So naturally, 3 is your more convenient number, and therefore you should convert all your 9s and all your square root 3 to a base 3 instead. That's how you should have your thought process in your head when you're doing such a question. Okay, so the answer here is not important, but the idea here is important. Okay, every time when you see a question with many different bases, okay, feel free to take a screenshot if you need to. What you should think of is change your base law. Choose the most convenient number as the base and then move on from there. Okay, why do you need to make everything the same base? Because what two rules require same base? Your addition rule and your subtraction rule. Your addition rule and subtraction rule will not be usable if there are no common bases. That's why you want to force out everything to be the same base, and then you continue the question from there. Okay, this is not say a foolproof method, but once you have this idea instilled in your head, right, I guarantee you this kind of question, you will not feel stuck anymore. You will at least be able to do the first few steps. Okay, now moving on to your, let me find a substitution question first. Okay, hold on. So previously, remember, I mentioned this common types of question that appear in this chapter. One of them is substitution, right? Look at your supplementary question, chapter 3, question 1. Okay, do you see that you have a 3 to the power of 2x and 3 to the power of x? And they ask you to solve for x. Can see that? This kind of question, immediately when you see this thing over here, these two things, you should tell yourself, is a substitution question. Why? Because if you substitute these two values, you are able to get your quadratic equation. Can you see that? If you let 3x be u, you can get a quadratic equation. Can see that or not? Okay. Remember at the very beginning of the log chapter, I mentioned that there are a few chapters that will kind of like seep into this chapter. One of them is quadratic equation, and this is the type of question that will appear. Okay, every time, this is an exponential question. Why is it an exponential question? Because there's a 3 to the power of x. Your x is in your exponent. So within an exponential question, you can see that if you do a substitution, you get a quadratic equation. Can see that? These are the type of questions whereby you see you should immediately tell yourself, okay, I need to do substitution, then I can continue the question. Because if I do substitution, I create a quadratic equation. Okay, I create a quadratic equation, and you know, after that,
do I know how to solve a quadratic equation already? Have I learned that before? I have. So I'm able to solve it, but this is not the end of it because you did a substitution previously. So you need to go and change back, okay? Because you let 3x be u, right? So now if you change it back, it will be 3x to the 3 to the power of x equals to the values over here. Then after that, how do you solve for x? This is where your log comes in. You want to make x the subject. You want to make the power the subject. What have you learned that help you bring down the power? There's only one rule, your power law. Okay, so you need to bring in your power law by logging this entire thing and this entire thing. So when you log both sides, you will be able to get the answer. Can see that? Okay, you can use ln as well. There's nothing wrong with that. So feel free to take a screenshot if you need to. This is the type of common question that will come out, the substitution one. Yeah. Okay, then now let's look at, yes? 3u squared. Okay, can you see that? Okay, how the question is, how do I get 3u squared? What did I let u be? 3x, right? Can you see that here is technically 3x to the power of 2? That's why I get u squared. And then why is there a 3? Because there's a plus 1. A plus 1, okay, let me break it down, equals to 3 times 2x. Can see that? That's why you get 3u squared at the end of the day. If you are struggling to see why this is 3u squared, it means that you need to brush up on your indices, okay? It's a very common problem to have, so make sure you study on your indices. Sorry, I'm not too sure what the question I just received means. So just substitute then can just substitute. Yeah, can you rephrase it for me? Okay, for the questions that were previously for the log graph drawing, for the questions that were previously directed to the log portion of the graph drawing, I'll answer them after class. So feel free to send me the same message later. Okay, now let's move on to part BI. So part BI, they ask you to solve this particular equation. Can you see that everything, almost everything has the same base already? So maybe you don't need to go and use your change of base. And then you see a number 1 over here. Then maybe you should think that, oh, I might want to convert it to a log 77. Okay, just some ideas over here. It is not exhaustive. So what do I mean by not exhaustive? There could be more than one method to do the question, but these are some things you can think about to help you simplify the equation so that you get closer and closer to the answer. Okay, so I'm going to flash the answers here. So you see, same thing. There are 2 solutions. There's more than one solution, okay? More than one method, sorry, to do the question. But it turns out that this question, there is no solution. Why is there no solution? Okay, because my answer is x equals to -6. Remember, for a log and exponential function questions, why do we even need to learn to draw the graph? Drawing the graph is because there are graph sketching questions and also because it helps us identify what answers to reject. If x is equals to -6, you sub it in here. You sub -6 into the graph. Can you see inside here will be -5? Remember our graph drawing. This is how a log graph looks like. Do you think it ever inches into the negative x-axis? It doesn't. So because this whole thing equals to -5, the fact that it is smaller than 0, you reject the answer. This is why you need to know the graph drawing. You need to know what the asymptote means. Understand? Okay, I'm just going to flash the answers over here. So feel free to let me know if you have any questions. Okay, what if they ask us to explain why the ending result is rejected? Okay, this is not rejected. This is no solution. Rejected means actually the solution exists, but then maybe because it is like distance, then my answer is -6. Then that is rejected because it exists, but we are talking about distance. That's why we reject a negative value. If they ask us to explain why there is no solution, you just simply need to say x plus 1 equals to -5, which is smaller than 0. Log log 7 -5 is undefined. So this is how you would explain it. Can? Okay, some of you look a bit lost. Feel free to ask me later if you have any burning questions. But now we gotta move on because we only have about 9 minutes left. Okay, so I'm not going to go through part II. I will just flash the answers. What I want to go through is part C. Okay, Mrs. Lim baked chocolate muffins and left them on the dining table to cool. And then, you know, this is the temperature given, what does big T means, what does small t means, and this is the formula of how big T and small t are related. They tell you that the initial temperature of the muffin is 180 degrees Celsius. Immediately, when you see this statement, you don't even need to read the other thing. You must tell yourself, this is trying to tell you that when t equals to 0, small t equals to 0, big T is equals to 180. Why do you need to know that? Because you need to create an equation to help you solve your unknown. Okay? So immediately you should tell yourself when t equals to 0, small t equals to 0, big T equals to 180. Then you start plugging into your equation and you can solve that. A is equals to 30. Okay? Yeah, so you should, every time you see this kind of statement, right, you tell yourself, you confirm need to use it as the first few steps on. Initial temperature, something happened. Initially, something happened. Part II, they say when T is equals to 10, the temperature of the muffin is 120 degrees. Find the value of K. So it's pretty straightforward, pretty guided. You just need to sub T equals to 10, and then you sub big T equals to 120, and you solve for K because you have already found A. Okay, and how do you solve for K? This is where your log and exponential comes in. That's why this is a log question. Okay, so this question you would bring in a ln you will bring in a ln so that you can drop the -10K from the power down. Okay, so they can drop it down. You can bring in a log as well, nothing wrong, but ln is definitely easier because if you bring in a ln, your E disappears. Can see that? If you bring in a log, there's nothing wrong. So what do I mean by that? It will be 10K log E equals to log 3/5. -10K equals to log 3/5 over log E. This will also be give you the same answer as this. Take note of my presentation. Notice that my K, I didn't just write the 3SF answer, I also wrote the 5SF answer. Why do you need to do that? Because you never know what will happen in the subsequent parts. If your subsequent part, like maybe part D, part E, require you to use the value of K, if you use the 3SF value of K, it is very, very likely you will get accuracy rounding off error later. So please make sure every time when your question has multiple parts, not just for this chapter, for every single A math question, if your question has multiple parts, please use a more accurate, please leave your working with a more accurate answer. Then the subsequent part, don't use the 3SF answer, use the 5SF, 6SF, 7SF also can. The most important thing is at least 2 more SF than your final answer. Okay? Ideally, you can even use the whole entire value you see on your calculator. That's fine as well. But I don't think you all have the time to go and punch in every single digit lah. So 5SF is the rule of thumb, the bare minimum. Okay, so 5SF, you can choose to round up or round down, or you can just cut it there at the 5th significant figure. It's okay, right? Okay, I choose to just cut it off in case if anyone is wondering, why I round down? It should be round up, that kind of thing. Okay, so part 3. Find the time taken for the chocolate muffin to cool down to 35 degrees. So it's pretty straightforward. You need to let big T equals to 35. But this is a context question. So you cannot just like take your answer and move on. Okay, this question you can, okay, but I need to rephrase the question in a way whereby you cannot just round up or round down. But let's look at the solutions first. Okay, so you set big T equals to 35, and then take note, you see, the K that I used is the 5SF answer. I didn't use the 3SF answer. And then I solve for T. How do I solve for T? I ln both sides. Can see that? Do you all know why I ln both sides? Okay, some of you look a bit confused. Why do I need to ln on this step? It's because T is in my exponent. I want to solve for T. In other words, I want to make T the subject. How do I make something in the power come down? We have only learned one thing before, which is your power rule. And how do you bring about your power rule? You need to ln it or log it to bring the power down. That's why I ln both sides. I ln both sides because there's an E. Ln E in your calculator is 1 because same base. Can see that? So after that, I get my T equals to this, and I can leave my answer in 3SF. Yes, 66.582. Okay, if I change the question, I say, find the time taken for the chocolate muffins to be at least 35 degrees Celsius. Okay, and leaving my answers in nearest minute. If I change the question, cool down to 35 degrees Celsius, leaving answer to nearest minute. Okay, it's a context question already. Now you need to be very clear whether you round up or down, and it doesn't just depend on this digit. This digit tells you 5 is round up, right? Because it's 5 lah. So nearest minute will be 67. But that is not the point of the question. The question wants you to find out the time taken for the muffin to cool down to at least, sorry, forgot to write that, at least 35 degrees Celsius. So can you see at the 66 minute, okay, it hasn't cooled down to 35 degrees Celsius. Only at the 66.6 minute, then it cooled down to 35. That's why your answer, you need to round up to 67. It is not because there is a 5 here, you round up. No, it's because you need to take into the context into account. For example, if my answer here happened to be 66.4, and the question, okay, 66.4, 172, whatever, and the question is still the same. The question says, find the time taken for the chocolate muffin to cool down to at least 35 degrees Celsius, leaving your answer in nearest minutes, okay? My answer will not be 66, it will still be 67, because at the 66 minute, it's still not cold enough. I must round up to the next minute, then it's cold enough. This is where the tricky part comes in, the context, the tricky context part comes in. This question is very simple because they didn't give any fancy context, but okay, unfortunately, we don't have time to go through, so I'll just flash the answer. But for example, like part B for this particular question over here, just a brief one, the number of days which the class will be cancelled, okay, the answer, even though is 17 point, oh wait, not this one, is there another one? Okay, never mind. Yeah, even though the answer is 17.3, we cannot just assume that's going to be 17. We have to take into account the context and whether it rounds up or down or not. This question, you kind of have to take into account the context. Okay, hold on. I'm pretty sure my answer here is, yeah, this is correct, yeah. So this one, feel free to take a screenshot if you need to. This is your question 7, chapter 3. Yeah, unfortunately, we don't have enough time to go through this question already. Okay. Okay, and then another question that you can take a screenshot will be question 9. Okay, if there's anything wrong with my solutions, feel free to flag it out. It's all done by hand, so I don't have like the final answer. Okay, Take a screenshot if you need to. This is question 9 of chapter 3. Okay, before you guys go, okay, I want to go through one more question, and this is actually from your other chapter, not log. This one over here. Hold on. Chapter 2, question 1. Okay, remember previously, okay, unfortunately we are rushing, so sorry if everything seems very rushed. But remember just now when we are doing our discriminant question, I mentioned something about there's always going to be a set question and a proof question. So question 1 is a very good example for that. Take a look at question 1. They say, find the range of values for P for which this happens. This is actually saying that, okay, it is always positive. So you're trying to find the range of values for P for which the graph is always above the x-axis. Can you see that? The fact that it's always above the x-axis, can you see is actually a set question already? They are setting the scenario. That's why the first thing I write is this statement, and then I start solving for P accordingly. Can you guys see that? But for part B, okay, don't just copy the answer. Make sure you understand the question. For part B, the question is different. They say, show that the equation has no real roots. Is the question setting any context? No, the question is not setting any context, okay? It's trying to ask you to show that there's no real roots. So it is not right to set this. You are supposed to show this. You are not supposed to set it. Therefore, the question, you need to go and find the value of b squared minus 4ac. And then remember, just now we had that full steps, right? Then to show that it's always 0, I mean always smaller or bigger than 0, we need to bring in completing the square. Okay, so this is exactly what's happening. Feel free to take a screenshot of the solutions if you need to. But this is the thing that I was trying to emphasize, a show question and a what's that called? A show question and a proof question. Okay. Okay, so this is the last question that we'll go through as a class, but I need to just go through some admin matters, and I need you guys to help me do a survey. Hold on, let me find the survey code. Please do not leave, because I really need you guys to help us fill up the survey about the event on what we can improve on. Okay, give me a moment. I need to find the QR code. Okay, but while I find the QR code, right? If you guys are interested in joining, I mean, there's no, what's that called? There is no, you don't have to join it just because you attended this, okay? But if you're interested in OVERMUGGED A-Math Tuition, here's some information. So these are the details for Sec 3. So we have Sec 3 classes for A-Math, E-Math, and these are the rates, and these are how they are like. So learning materials are provided. So what you have today, right, like what you're holding, these are usually like, this is the standard of our materials for normal tuition lessons. And then, you know, we will give consultation upon request, and we also give homework. That homework can come in the form of just worksheets, mock exam papers. You can attend online, okay? You can attend physically. So what we do is it's always a hybrid lesson. So it's like online, physically. So usually students will opt for physical lessons, especially the parents. They feel like physical lessons more worth it. Okay, but physical, as you can see, there's a constraint. We only can fit 12 people. So benefits include, I mean, other benefits besides, you know, educational benefits. We have online resources. You know, that QR code that you have in your notes, those are one form of it. And we also have like welfare. We have snacks outside, you have snacks in your goodie bag, and there are times that there's bubble tea lah. Okay, so if you're interested, these are information about the tuition. And then if you are keen to join, we have some free trial lessons. Okay, so for my class, if you're interested, you can attend one free trial lesson before you decide whether you want to join or not. There is no obligations or anything. It's just like that. But do take note, there is only one free trial lesson, so you cannot keep coming lah. Okay, and yeah, this is the timetable. And the most interesting one, I think, is this. Okay, this is more relevant for current students. Okay, I know that there are current students attending this end of year event. So next year, our referral system is quite interesting. For every one new person you refer, you get $100. Okay, it's like hard cash. Okay, you get $100. And if you refer 4 or more, you get free AirPods Pro. I don't even have free AirPods Pro. Okay, this is honestly a bit over the top, but it's my boss decision. He want to give this. So if you guys are interested, and if you as a friend group are interested, one of you join first, then you refer all of them. Okay, don't join together. Okay, take advantage of this benefit. Okay, don't like join all at once, or else you cannot get this referral benefit. Okay, but it only applies to from Sec 2 to Sec 3. I mean, next year Sec 4 still okay, but this year Sec 4 not okay already. Okay. Then, okay, so resources at your disposal, we have mentioned this before. This is, we have our EOY revision kit. Okay, those of you who haven't collected it, do you all have this because you all came late? Okay, yeah, so same thing. If you're interested, please come down to the center to collect it. We printed a lot of extras. Sorry, yeah. And then our OVERMUGGED website also has notes. So if you feel that you need more revision, feel free to go onto our website and just download everything. It's not just for math, there's all sorts of subjects. Honestly, I have no idea what subjects they have, but definitely the core sciences are there. Physics, chemistry, bio. If you're interested, download. This one's all free one, just take. Okay, and then AMath group classes, if you're interested, you can personally message me or message our admin. So these are some of the group tuition timings that, if you are interested in, these are the timings that we currently have. Okay, I still have to pull out okay, if you need to leave now, I won't keep you, but if you have the time, please help me do this survey. I'm trying to find the survey QR code, sorry, yeah. Yeah, if you all don't have any questions, feel free to leave. Thank you. Sorry to keep you guys waiting for those who are helping me with the survey. I'm trying to find the survey QR code. Okay, sorry, give me a moment. Okay, so your responses are greatly appreciated so that we can improve like future events similar to this. Okay, sorry, give me a moment. Okay, for the questions that I'm getting on Zoom, I will get back to it. I just need to flash the survey thing first. Okay, give me a moment. Okay, this is the QR code. Hopefully it works. Let me reshare my screen. Oops. Oh no. Sorry, something is happening. I cannot join back. Oh, am I already inside? Oh, okay, sorry. Okay, sorry. No, I wasn't. Okay, sorry, I was kicked out of my own Zoom, so there's some issue with the audio. Okay, for those of you online, if you guys have any questions, can you please resend me? Because I got kicked out. I cannot see the questions anymore. So yeah, resend me the questions. And I understand that you guys are interested with some of you are interested in the questions that we didn't have enough time to go through. So if you need to leave, feel free to leave, but I will be flashing the answers over here. Okay. So for chapter 1 and 2, there are a few questions that I actually have the solutions for. Feel free to take a screenshot if you need to. Okay, these questions that I picked, right? They are, how do I put it? They are questions that are more commonly seen, and also in a way, if you manage to solve it once, you will manage to do it again and again and again. That's why I picked these questions. It's like very practical in the long run. Okay, question 2. You want to is it? English, English, I think don't have. Oh, okay, sorry. Oh, the AMF one. Sorry, where did I put it? I think it's here. Oh, is it? Oh, yes. Okay. Yeah. Okay, for those of you physically, you can feel free to take the revision packages, but don't take too many per person. Okay. Oh, I had a calculator. Okay, and then there are more questions over here if you all want to screenshot anything. Thank you. Sorry, it's a bit rushed towards the end. The answers might not be in the Telegram group, so sorry about that. Okay, so if you want to take a screenshot, because the answers provided if there are answers provided by the Telegram group, it wouldn't be just from me. It will be from all the math tutors. So it might not look exactly the same as this. Oh, for the other questions. Okay, if the other questions, same thing, there's no guarantee because we don't have answer keys for all these questions. We are doing it on our own. Because school papers, they don't provide the answer keys to outsiders. Okay. So this is the other question. Okay, I have a question. If you write phi SF, do you write equal or the squiggly lines? Honestly, you can just write the equal. Okay, squiggly lines is very lower secondary school standard. Okay, so if you write squiggly lines, nothing wrong with that, but feel free to just write equal sign. And if you feel that it's better, you can always bracket phi SF at the back. Okay. Okay, for those of you who have questions about log and everything, you have to resend me because I got kicked out of my Zoom. I cannot see the old questions anymore. Okay. Thank you. Oh yes. Thursday can or not? 6 to 8. Oh, 6 to 8. See the book. Yeah. Can. See you again. Okay, sorry, there's a lot of questions flowing in, so I need to take some time to read it. Okay, what are the criteria for log to be undefined or rejected? You need to use the log graph. Okay, so if your answer, if you know the log graph shape already, right? For example, you know that your log, okay, one way is to use the log graph. If you know your log graph shape looks like this, for example, and you have an answer that is like x is equals to -10, definitely your graph doesn't even exist here. Therefore, you reject such an answer. Another way is to just sub it into your log function. If you sub your answer into the log function, okay, and you get something inside the bracket that is smaller or equal to 0, okay, if you get something that's smaller or equal to 0, you will have to reject the answer. So for example, oh no, my iPad is running out of battery. Give me a moment. Okay, for example, if your graph, if your log function is LG 2x minus 1, and you solve that your x equals to 2 or -5, you will reject x equals to -5. Why? Because if you sub -5 inside here, okay, you sub -5 inside here, this whole thing is -11. It will not make sense. From the graph shape, you can see that -11 as x will not exist, right? And also you can key into your calculator, log -11, you will get an error. So how you decide whether to reject an answer or not is after you solve for it, you sub it back into the logarithmic function in the question. Okay, another question is, can you recap how to key in quadratic equations into your calculator? This question a bit worrying, but okay, no worries, I will go through. Very important, okay? Your calculator is your best friend. Please make sure you know how to do this. If you are using a Casio calculator, click menu and then go to equation function mode. You might have to click the down button. Okay, yeah, my calculator is cool, it's pink. Okay, but go to menu first, okay? And then you go and find your equation function mode. So click this over here. Okay, it might look slightly different based on which calculator you are using. So mine will definitely look different from the typical Casio one. Okay, sorry, let me reshare my screen. Then after that, you key in, you select that particular mode, right? Then you key in polynomial and select degree 2. Why you select degree 2 is because degree 2 is power 2. You are trying to key in a quadratic equation, and a quadratic equation, the biggest power is 2. That's why you click 2. Okay. Could you show, okay, so that question is done. Could you show chapter 2.1 again, the solutions? Okay, hold on, let me reshare my screen because my iPad is running out of battery. It keeps disconnecting. Okay, hold on. Chapter you wanted. Chapter 2. Okay, hold on. So this is chapter 2. Okay, another question. For the log graph, when you draw the intersection, you just write 1 or must you write coordinates like 1, 0? Okay, if you are marking out a coordinate like this, okay, you can do this. Okay, sorry, it's not going to be 0 and 1. Let it be A and B, okay? You can either choose to do this or, okay, sorry, this is not even an intersect. Bad example, sorry. You can either do this, so maybe A0, or you can do this, A. So it's slightly different. It's just a different way of presenting your answers, but both of them are acceptable. Okay, any other questions you guys need to take photo of? Okay, do I know if there's any English revision booklet at the Serangoon Tuition Center? Okay, unfortunately, I'm not based at the Serangoon Tuition Center, so I am not sure if they have it there, but I don't think they have an English booklet because just now there were students that were asking for it as well. So unless you are very sure that there is an English booklet, okay, I can tell you that the Bukit Timah one also don't have already, so sorry about that. Okay, we might not have an English booklet, so I'm not too sure if we even have that. But if you are intending to come to Bukit Timah, okay, we still have almost all the subjects minus English. Let me just double check. Yeah, meanwhile, if anyone has any other question, keep it coming. If anyone, okay, no problem. Thank you for attending. Yeah, if you all like my lesson, feel free to give me a good what's that called? A good review, I guess. Or if you want to learn more from me, you might want to consider regular lessons. Okay, when to use reject and no solution? Okay, this is a good question. Honestly, at least for O-level, it's not very strict. They don't really care if you write reject or no solution. But when you need to reject or when you need to, don't accept the solution, at least mark it out somehow. Reject is more of like, there is a solution, but because of the context, you reject it. So for example, I cannot share my screen anymore because my iPad is dying. If you have x equals to 8 and x equals to -5, and we know that x is a distance, okay, obviously you have to reject x equals to -5 because x is a distance. But does it have a solution? Yes, because x equals to 8 is a solution, x equals to -5 is also a solution. But -5, you reject it. Okay. Anyone has any other questions? Okay, thank you. Okay, make sure you all remember quadratic formula, don't forget. Sing the song if you need to. Okay, show the solutions. Hold on now, my iPad is dying, so it doesn't let me connect properly. Let me try again. Okay, yeah, can. Question 5, chapter 3. Do I have 5 and 6? I don't think I have 5 and 6 left. Question 5 and 6 for chapter 3. I don't think I have it. I only have this one over here. Unless you're talking about this one, question 7. Okay, the question before that. Okay, this one. Question 1. Okay, this was the one that we actually went through. The main takeaway is the context. Okay, make sure you understand the context and identify the answer accordingly. It's not always round up, not always round down. Question on page 33. Hold on. Page 33. Okay, the question on page 33. Oh, I don't think I did that question. So I don't have the solutions for those. Okay, I don't have the solutions for those because I didn't do it yet. So unfortunately, I can't share that with you. Alternatively, you might want to search online for the solutions, but I highly doubt that online have. If online have, I will also have the solutions already. Okay, but some of the questions definitely online you can find the solutions, especially for the later papers like the 2020, 2021. Okay, let me just, will the solutions be posted on the Telegram group? I cannot confirm with you. If there is, okay, keep a lookout on it. It will probably be posted by our other math tutor, Kai Wen. Okay, but if there's no, like, you know, anything, there's no announcement, then we wouldn't be able to, that means there isn't any solutions that we can share. But I believe he will share at least some solutions, maybe not all the questions. Okay, maybe at least those that we already have the solutions, he will share it. So keep a lookout. And we also have a session 2 for AMath. So if you attend session 2 and you know, we have already released the solutions by then, I will let you guys know in session 2. Okay, no problem. Thank you. Anyone has any other questions? Yep. Okay, thank you. Okay, if no one has any questions, I will end this call in about a minute. My iPad is dying, as you guys can see. So yeah. If no one has any questions, I will end it soon. Okay, I'm assuming that no one has any questions. So thank you for attending. Hope that you can, you know, this lesson was interesting and you take away something. Don't make the common mistakes already mentioned in your upcoming EOY, and all the best. Maybe I'll see you next lesson. Okay, my next lesson will be on 10th of September, the Sunday, 4 to 6 p.m. So the other lessons I will not be teaching. It will be our other tutor. So yeah, see you guys. Bye.